You've seen photographs of Earth from space, that pale blue dot wrapped in green and white. But billions of years ago, this planet wore an entirely different color. Before a single tree, before the first flower, ancient microbes ruled this world. And they painted it, from shore to shore, in deep, vivid purple. These organisms, ancient relatives of modern archaea, used a pigment called retinal to harvest sunlight. Unlike modern plants, they absorbed green light and reflected purple. This created what scientists call the purple Earth hypothesis, the theory that for hundreds of millions of years, our world glowed violet from space. The shallow seas teemed with these purple organisms, layering themselves into rocky formations called stromatolites, fossils of which still exist today. Eventually, green plants evolved with a more efficient system, chlorophyll, and slowly, over millions of years, they overtook the purple world. The purple world vanished, replaced by green, swallowed by time, known to no human alive, until science dared to look back far enough to see it. Every civilization in human history has looked up at the same moon. One moon. But 4 billion years ago, there were two. Scientists believe Earth's moon formed when a Mars-sized body called Theia slammed into young Earth. But Theia may have left behind more than one piece. A 2011 study proposed that a second, smaller moon, perhaps 1/30th the size of our own, formed from the same debris cloud and quietly took up orbit. For millions of years, two moons rose and set over a barren Earth, casting twin silver shadows across boiling oceans that no eye ever witnessed. Slowly, gravitationally, the smaller moon began its inevitable journey. Over millions of years, it spiraled inward, toward its larger twin. The collision wasn't an explosion. It was a slow, silent merger, a gentle cosmic kiss that may have created the mystery of why our moon's far side is so different from the near side. The lunar highlands, those ancient rugged mountains on the far side of the moon, may be the grave of Earth's forgotten second moon. A silent monument to a sky that was once very different. Imagine standing at the equator. The tropics. Warm breezes. Gentle sun. Now imagine that same spot buried under 2 miles of solid ice. This actually happened. Twice. Around 720 million years ago and again 635 million years ago, the entire Earth froze solid, from pole to equator. The snowball Earth hypothesis suggests average global temperatures plunged below -50 degrees Celsius. Ice kilometers thick covered every ocean, every continent. What caused it? Volcanic activity decreased. Carbon dioxide in the atmosphere dropped. Ice began to form at the poles, and the bright white ice reflected more sunlight away, making Earth colder still. But life did not die. Deep beneath miles of ice, near hydrothermal vents on the ocean floor, primitive organisms clung to warmth, surviving the impossible. Meanwhile, beneath the ice, volcanoes kept erupting. CO2 built up with nowhere to go. After millions of years, the greenhouse effect cracked the planet open. The thaw was violent. Floods of biblical proportion. Temperatures swinging from -50 to over 50 degrees Celsius, all within a geological instant. From that frozen near death, life surged. Within 20 million years, the Cambrian explosion, the greatest biological diversity event in Earth's history. You are breathing right now, effortlessly, but step onto the surface of early Earth, and that first breath would be your last. For the first 2 billion years of Earth's existence, the atmosphere contained virtually no free oxygen. It was dominated by methane, ammonia, carbon dioxide, and hydrogen sulfide. Then, around 2.4 billion years ago, something tiny changed everything. Cyanobacteria, microscopic blue-green organisms, began producing a byproduct as they fed on sunlight. That byproduct was oxygen. And to every living thing on Earth at that moment, it was not the breath of life. It was a deadly poison. This event, called the Great Oxidation Event, triggered Earth's first mass extinction. Billions of organisms that had thrived for over 1 billion years were wiped out by a single gas. For millions of years, oxygen was absorbed by iron in the ocean and rock, turning it to rust. The ancient red iron oxide deposits we mine today are the scars of that age. Once the iron was saturated, oxygen began to fill the sky. And those organisms that had survived, those few who adapted, became the ancestors of every breathing creature alive today. The poison became the elixir. The catastrophe became the gift. Life doesn't just survive change. Sometimes, it is built entirely from it.